Welcome to Math Mini Lessons. My name is Sarah, and in this video, we're going to break down the 2025 June Regents, which actually threw me for a loop and a few teacher friends of mine. We were so used to seeing the Regents the same way year after year that this test actually surprised us. You're going to notice a lot more inequalities on this exam. You're going to notice systems of equations, systems of inequalities, quadratics with systems, standard deviation, all these things that don't often come up on Regents exams. But we can be prepped and ready for that. I'd much rather you be prepared and know how to break down the math problems than try to just take it cold and think you're going to rise to the occasion. With that said, here's what I want you to do. In the description, you're going to see links to not only the test itself, but a graphing calculator you can use on your own, on your computer or iPad if you don't have one at home. Take the test for yourself and then come back to this video. You'll see that I've broken the test up, the whole video up into questions, and you can skip around to the questions you want to see. So I'm going to give you the answers, and then I'm going to show you the breakdown right afterwards. If you want to see the breakdown, keep watching. If you just need the answer, you can just watch that part and keep skipping through. With that, at the very end, I'll show you how to convert your score and how many points you would have gotten if you had taken that June Regents, and how to use this to help prepare for the next one and to train in a smart, more efficient way than just aiming for a specific number. All right, with that said, if you have other questions or if you think I could explain it better, put it into the comments. If you like some of the ways I explain it, put that as well. That's really helpful for me as I'm making videos. And if you have other methods that you want to show, add them in, because you're going to be able to teach me something. Or maybe you could show me a way that I haven't seen yet or that I'm not showing to my audience that could really be helpful. So with that said, thank you for being here. I hope you join the channel. I hope this makes it easier for you, that you can see math is doable, that you like how I explain. Let's jump into the first chapter, which is the next set of questions 1 and 2. Here's the reveals for questions 1 and 2. My answers are 3 and 2. Stay here if you want to see the breakdown. If not, move on to the next chapter. All right, so in the first one, we're looking for what is equivalent to 10 divided by the square root of 2. Now, obviously, I can't divide this because I have here an irrational number. So when this happens, what we can do is we can use a property of 1. What I mean by property of 1 is I'm going to multiply this number by a value that is equal to 1. So we're going to have the same numerator, same denominator. And because I have a square root 2 on the bottom, I'm going to multiply this by, I want a denominator square root 2 and square root 2. So you see why I'm doing this? Because this is equal to 1. I'm still multiplying by 1. But because I'm doing square root 2 times square root 2, my new denominator is now 2. And on top, my numerator, I have 10 square root 2. This is something that we can actually work with now, because I can do 10 divided by 2 to get 5 and square root 2. Alright, so let's hit pause here and jot this down into your notes. And again, if you're wondering, well, how did you get that again, Sarah? Well, again, all I did was I divided 10 by 2 to get 5, and then the square root 2 was what remained. Let's look at number 2 in the second one. I want to know which interval, that's my key right over here, which interval the parabola is increasing. And I could, like, when is it only increasing? And I can see that it's happening on this part of the parabola. So let me put this into a different color. I'm going to look at the vertex here, because it's at this point right here where my parabola turns around and all my values are now increasing. It happened over here where x was equal to 1, 2, 3. All right, that is my vertex for this parabola right here. And it starts from there and it keeps on going to infinity. So every point is going to keep on going this way. Infinitely is going to stay in the positive. And that is why it starts, and I'm going to use this symbol here. So it starts when x is at 3 and it never ends. Oops. So this is my start, and it goes on forever in this direction. Okay, it keeps going, keeps on increasing. So I can use that interval from when x equals 3 all the way infinitely in that direction, and that is why my answer is 2. All right, hit pause and jot this down into your notes. Let's look at numbers 3 and 4. The answers for 3 is 4, and the answer for 4 is 3. Alright, let's start with number 3 if you're still here. We wanted to know which one of these represented an exponential relationship. And when we see exponential, automatically you should be saying to yourself, not linear, and it's not a constant change. Meaning it's either going to rapidly grow, it's either going to grow real fast, or it's going to decline really fast, but it's not going to be in a straight line. It's not by a constant. It is definitely not a rate. Which is why for the question 3, number 4 makes the best choice, because his business is growing 5% each month. So when I see this is telling me that it is compounding. And it's compounding with the magic of time. I have videos about how time is a superpower when it comes to compound things like interest. And because each time it is increasing by 5%, and the next month it increases by another 5% and another 5%, and it just grows magically over time. So and a lot of kids look at this and they can just see with the percent part, they'll start thinking, I can recognize this is not a rate. It's not a rate. But with the other ones, we can definitely see the rate. So with number 1, we're losing 1 pound per week. That is a rate. Or 5 points each quarter, so 5 points every 3 months. That is a rate. And I can see why some kids would have said, well, quarter, and thought maybe that could have been the correct answer. But when they're talking about quarter, they're talking about a specific amount of time. And the last one we're looking for, he wants to reduce it $50 per month. All right, hit pause and jot this down into your notes. All right, for number 4, we are going to use the calculator, not so much because it has to do with average, but because this type of question is asking us about statements with standard deviation and mean. Like all these choices, we're looking for which statement is correct, and they all have to do with comparing the mean and the standard deviation for Joe and Andrea's scores. So what does this even mean? Well, mean we know is an average, and it says if we took all these numbers together and we made them all equal, that would be the average. That's kind of was like, if we spread them all out, made them equal, what would it be? But for a standard deviation, we want to know how close or far away those numbers are from the mean. So that's what we're looking for. And what I'm going to do with the calculator is we're going to go to Stat, and we're going to go to One Edit, and I'm going to put Andrea's numbers in first. And this function will help us calculate all the statistical stuff we need. In other words, we're going to be able to see the mean and standard deviation pretty quickly. So once you have all those numbers in there, you're going to hit in the second row, and next to the green alpha, go all the way to the right. You're going to hit Stat, and now I'm going to hit Calculate, and one variable statistics. So we're going to hit number 1. Enter, 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 and you're going to look for this symbol, the very first one. That's going to be your mean. So for Andrea, her mean is 85.75. So if I took all these all together and I made them even into one number, this would represent all of them, a nice even number. That's her test scores. But her standard deviation is 3.5, meaning her points are, all her test scores are very close to the mean. All right, so that's Andrea. And now we're going to do the same thing for Joe. So I'm going to go back to Stat. We're going to go to Edit. Hit up. I'm going to clear the list, and I do this so I don't get confused, because I don't, in a state where I'm very nervous or I'm feeling anxious, there's so many places where I could make mistakes. So I'd rather be careful and super focused on a few things than try to multitask with lots of different numbers. So here are my numbers. I'm going to do the same thing. I'm going to hit Stat again, move over to Calculate, one variable statistics, enter, 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 and now I have his numbers. So his mean is 82.5. That's his average score, but his standard deviation is way larger. It's 12 point, I'm gonna round this, 12.45, meaning his scores are farther away from his average. And that kind of makes sense, because we can see here they go as high as 90, actually as high as 94, and as low as 67. So they're way more spread out than Andrea's scores, which are very tight and close together. Her highest score is a 90 and her lowest score is an 82, and those are much closer to the average of 85. So this is why 3 is the best answer. Andrea has the larger mean. 85 is higher than 82, but Joe has the higher standard deviation with 12 and 45. His numbers are more spread apart than Andrea. All right, hit pause and jot this down into your notes. Here are the answers for 5 and 6, 4 and 1. All right, stay here if you want us to break down. If not, keep moving. So for the first one, we're looking for the polynomial that has a degree of 3 and a leading coefficient of 2. Meaning, just by looking at this, the leading coefficient has to have a 2 in front. And because my degree is 3, I'm looking for x to be to the third power. And because this is leading, my leading coefficient, all the other numbers is here. Maybe you'll have an x to the second or an x to the first, whatever. But the only one that's going to have x to the third is going to have a 2 in front. And that's why 4 is the answer. It is the only one. When you look here, my leading coefficient is 2. And you can see it goes to the third power. That's my degree of 3. The other one that has a 2 in front, notice the 2 in front of coefficient, but my leading coefficient here has a degree of 2. That's why that one's wrong. And with the other one, what could have been the mistakes here? This could have been maybe a kid multiplying those two numbers together, a 3 and a 2. So I could see possibly why a kid could have chosen that, but unfortunately that's incorrect. And for this one here, they just mixed it up. If you chose 3, you've mixed up degree and coefficient. This has a coefficient of 3 and a leading degree of 2. All right, let's go to number 3. And in this one, we're looking for which expression is equivalent. Now notice here, I honestly don't even look at the choices yet. Instead, I'm going to do the work. And I'm going to do this by, I kind of want to show both ways. I'm going to show a stacking way and a distributive way. They're both really distributing, but the form is a little different. So I'm going to start with the first set. Negative 3x squared. And I see plus 9, so I'm going to put 0x plus 9. And on the bottom, I'm going to distribute my negative sign, my negative 1. So I have minus 7x squared plus 5x minus 4. And now that it's stacked, I can multiply it. Not multiply, I can actually combine these and kind of just add straight down. Like I can work these out because all my like terms are stacked up. That's why I like this way a lot. So 9 plus a negative 4 is just positive 5. Here I just have 5x. I'm not adding anything. And here I have negative 10 squared. And that gives me the answer for 1. So another way I've seen some kids do this is they'll put in their answers. They think linearly. And they want to just distribute. So they might put the negative 7x squared plus 5x minus 4. And you can do that too. I just like putting my like terms next to each other. So notice how like I want to put things that are the same. And then I like to rewrite it so they're right next to each other. And that way I can put these parts together and go, oh, these together make negative 10x squared plus 9. Oh, sorry. Plus 5, because these two are like terms. And plus 5x. And then if you wanted to write it in descending order, then you would write it the same way, which is 10x squared plus 5x plus 5. Either way works. Pick the one that works best for you. Hit pause and jot this down into your notes. Okay, let's look at number 7. The answer for this one is 1. Stay on if you want to see how I figure this out. And in this one, we want to find for weeks between weeks 4 and 12, what is the average rate of change? Okay, so when I think of rate of change, ROC, you can either think of it as change in y over in change of x, or you're thinking of it as y1, y2 minus y1, which is still showing the change, and x2 over x1. Either one works. And you may be going, but Sarah, I don't see a y. You're still looking at this column here, so h of h, x of h. All right, so what I don't want from the beginning to the end, I want specifically from this point, from this week when it was 12 inches to this point when at 12 weeks when it was 60 inches. So those are the numbers I want. This would be my 1s and my 2s. Okay, so all you're going to do is plug in those numbers. So we're going to start with the h of x value. So I have 60 minus 12, which gives me what? 48. And then what my x is, 12 minus 4, which gives me 8. And I can simplify that. 48 divided by 8 is 6. And there's my answer, 6. So that is my change. In between those intervals, my rate of change was 6 inches per week. All right, hit pause and jot this down into your notes. All right, let's look at 8 and 9. The answer for 8 is 4, and for 9 is 2. For number 8, all we're looking for is how did we go from this to this? What step did the person take? So a lot of times me writing it, like looking at it, I don't see it until I actually do it. And looking at it, I'm like, well, how did they get to this for this to be a 0 from an equation? And what they would have had to do is they would have had to create a 0 pair, meaning they would have had to subtract negative 3x on both sides. And they would have also had to subtract 3. So I'm going to expand this out. They would have subtracted 3x and subtracted 3. And then it would have been set to 0. Okay, and now this would have simplified to x squared plus 2x minus 3 is equal to 0. So that's what they did to get to that next step. And now I just have to think which of these properties does that. And I know I subtracted, and that's why we did the subtractive property of equality. We subtracted these terms from both sides so that the equations were equal. So there was still a property of equality to it. It doesn't make sense there's a 0 product because I didn't multiply by 0. It doesn't make sense it was commutative. That just would have moved around some of the terms. And we definitely didn't distribute anything. We didn't multiply multiple groups. So none of those made sense, but it should have been the most apparent that we subtracted so that we would still have an equation of the same value using the subtraction property of equality. All right, with the next one, that's why I have the calculator here. You can see it's already set to y equals, because we need to figure out which one of these functions represents a graph when wx is equal to the absolute value of x. But I want it shifted to the right. Okay, now if you don't remember what happens with absolute value, you can just, this is one of the things that I usually do. For x equals, I'm just going to put absolute value of x. We're going to just start with that one. If you're staring at the calculator and going, I don't see that absolute value symbol, you're going to have to hit the math key. So it's right under the green button, so you're going to hit math. And then we can move over to number. And there, boom, there it is, number 1, absolute value. So now you can hit 1, and we have our absolute value part, and we can put our x in there. Okay, so there's our first one. And so if I want to just see what this looks like, boom, I just want to see this, but I want it shifted over to the right. So how does that happen? Now, if you had done one of our lessons on absolute value functions, you know that you're either looking for in here x minus h or x plus h. One of these is going to be the function that moves it left or right. And this is the one that always confuses kids. Happens all the time. Because if I want to go to the right, I have to go to a negative number. So this one will make me go right. And this would make, if it was positive, it will go left. That is counterintuitive because every number line we have seen for so many years has the positives on the right and the negatives on the left. And so I think sometimes when kids see that, they try to memorize it, they think of it and they always mix them up. Always happens. So let's say you actually don't remember this at all. You don't remember these shifts. Well, that's okay. You can still go to your y equals, and what I will recommend is you can literally just put the next one in just to see what would happen. So I could try number 1, which again I have to put in absolute value, so we're going to go, not number log, I want math 1, and then you can just put your x plus 2. So you can try it and see if this happens, and when you hit graph, now your red one, did that shift to the right? No, it shifted to the left. Oops, I want to write it in here. So this went to the left 2 times. That was my red. So that's not what I want. I can eliminate this one. So I can go right back to my y equals. And now instead, I'm going to go to number 2, which is, what if this is minus 2? And you can hit graph, and boom, you can see that now my red is 2 to the right, which is what I wanted. Because my blue was my standard, and I've seen my red is now 2 to the right. So if you want to see the other ones just to see it, you can just go back down. And this one's asking us to clear it. This is just x. And this one is x plus 2. So let's say you want to just check the other ones and see. You can just graph it, and you can see the other functions. This made it go up. And this pattern is going to make it go down. So I'm going to go back down to it. And instead I'm going to have a minus 2, and boom, my red has gone down. So again, that's why I like being able to recognize patterns. But if you didn't remember this pattern, you can literally just, I would take the parent and I would graph this one first, and then I would just graph the other ones one at a time so I see the shift that I'm looking for. Alright, hit pause and jot this down into your notes. Let's look at 10 and 11. The answers are 3 and 2. So for number 10, we have systems of equations, but they want us to use specifically the substitution method. And the key to this is we're looking for an access point. Like, where is a point where I can say y is equal to or x is equal to? So you're going to really look for one of the terms that has a coefficient of 1 or just no coefficient in front. And I can see that right here, that y it doesn't have a coefficient. That's the one I want, because I can very easily turn this into a y equals using some type of property of equality. So what I mean is I can take this y plus 4x equals 5, and I can very easily make a 0 pair by subtracting the 4x, and now I have y is equal to 5 minus 4x. This is something that I can sub. That's what I want. So now I could take my second equation, 2x minus 3y equals 10, and now I can sub in for that y right here. So 2x minus 3, and now I can pop in that 5 minus 4x is equal to 10. And now we can just distribute. So that's the key to this. So negative 3 times 5 is negative 15, plus 12x is equal to 10. And we can, that was just me just working all of it out. Now notice how in the problem for number 3, they literally just left a 5x. So these two just match. So I didn't even have to do that. I kept on distributing. Here I can literally see where they distributed for the y. Alright, now another way you could have looked at this, like let's say you didn't see it at first. You could have looked at your choices and said, I see the x in all my choices. I see only a variable of x. I don't see any y's. And that would have been another hint that they substituted for y. Okay, now you may say, well, how do I know I'm not using the second one? Well, because if I would have used the second equation, this would have been way more complicated to set this equal into a y equals. One, I would have to subtract the 2x, and now I would have to divide everything by negative 3. So that just was too complicated here. Again, not impossible. It still works. But here, the access point was really with that y that had no coefficient. Okay? So that's why that was just a simpler way. Alright, so that's number 10. Let's move on to number 11. We're looking for which equation is the most equivalent to this quadratic. X squared minus 6x is equal to 27. Now this form, when I'm looking at this, I'm already thinking complete the square. It's already coming up in my head because I can create a visual of this where I can have, here's my big square, and here's my x, and now I'm going to half this one. So I'm going to put -3 over here, and on this side I'm going to do the same thing, -3. Okay, because then each of these little squares, this is 1, so this is -3 times x, so here is -3x, and here's the same thing, here's -3 times x and -3x. So I still have x squared and -3 and -3x, and that gives me -6x. So what would I need to complete this square? And that's why I like this visual, because I can literally see it is a 3 by 3 square, or my magic number here is 9. So I can add 9 to complete this square. So that is the key to this one. Now, how do I represent this? I could represent this as x minus 3. That's what I'm seeing here. I have x minus 3 times x minus 3 squared is equal to 27 plus 9. Because remember, we added 9, so I need to add 9 here. And that, my friends, is where number 2 is the answer. I can literally see, here's my x minus 3 squared, and then the work that we did on this side. Bam! So again, I love the visual, so you can, if this really helps for you, you can hit pause and jot this down. If this doesn't, if you want to see it algebraically, I'll show you that one as well. So let's say you want to do it only algebraically. You would still do the same type of step, which is to take half of b, the b term, and square it. So half of -6 is -3, and you would square it, -3 squared, and that will give you +9. But remember, we would also have to add that to the other side, the +9. Now, so that at least we can see this part is the same, the 27 plus 9, but then you would have to recognize that this would now be x minus 3 times x minus 3, or x squared. So that's the challenge with this one algebraically. It's kind of why I love the visual a little bit more, but I recognize that some kids would rather see it algebraically done and see how to get the answer. Okay, so let's hit pause here, see how I factored the numbers. And again, you could have just also then represented this as -3 squared is equal to 27 plus 9. Hit pause and jot this down into your notes. For number 12, we have our box and whisker plot. The answer for this one is 1. And there are just some terms that we have to know for box and whisker plots. Usually when we see them, and I'm just going to draw one out here so you can just see visually all the things that will come up. Obviously, we can see the box. Inside the middle of the box, you'll see a line. This will represent your median, your middle number. The first line outside the box is your Q1. The other side of the box will be your Q3. And you might be thinking, well, where's Q2? Well, the medium is actually the Q2. And it goes to the end, which would have been your Q4, or your largest number. This would have been your maximum number. Your minimum doesn't have a Q in front. It's just like the starting point. The other thing that you're going to look for when you have box and whiskers part, you might see an IQR, which means interquartile range. Or going from here to here, what is the range from your Q1 to your Q3? And you can just figure that out by doing Q3 minus Q1. That's how you figure that out. Alright, so now let's look at what we have here. in this answer, and why is number 1 the correct answer? It says because the IQR is the same for both teams. For the swim team, my numbers go from 12 to 16, so my IQR would have been 16 minus 12, which is 4. And for the track team, it goes from 10 to 14, which is also, if you're doing it in your head, your IQR, you're doing 14 minus 10, which is also 4. So that is why number 1 is the correct answer. So why are the other ones not correct? Because that's what's happening. We're looking for the one absolutely true statement, and we should be able to discern or figure out why the other 3 are false. So with the first one, it says there are more athletes on the swim team than the track team. We don't have that information. There's not enough info to tell that. So that's number 1. Now, where I can see some kids getting lost in this and being tricky is because they might go and say, hey, well, this one goes to 17 and this one goes to 15, so this one must have more. It's not what it means. Our numbers go from there, in this case, let's see, the ages go from 9 to 17. So that's the big key here, that these are ages, not number of kids. So we don't have that information. Number 2, the median age. That's something we can see, and that's that little line in the middle, right over here, and over here. So our middle ages, the median age for the swim team is 13, and the middle age for the track team is 12. So 13 is not less than 12. That's why that's not a true statement. The median age of 13 is not less than the median age of 12. Not a true statement. And the last one, they just want the full range. So that means going from the beginning to end. So for the swim team, if I want the full just range, I'm going to do 17 minus 9 gives me 8. And if I want the range from the track team, my maximum is 15, my minimum is 8, and that gives me 7. Alright, so the range of the swim team is smaller, so 8 is smaller than the range of the track team 7. That is also not a true statement. Okay, and again, all I did for range was I did my maximum number minus my minimum. And that's it. That's why the other 3 are false statements. So hit pause and jot this down to your notes. Box and whiskers is usually being able to pretty much interpret the graph in front of you, and you have to know the vocab terms and what some of those symbols actually mean from the visual. Alright, let's look at number 13 and 14. The answers are 3 and 4. I have my calculator here for number 14. We'll start with number 13 here, and we want to know the domain of the function. And when I think of domain, we're thinking about our inputs or x values. And looking at the graph, I noticed that it starts over here with the open circle and ends over here. So it starts from where x is equal to 0, and it ends where x is equal to 12. So I'm going to write this first kind of like as an inequality so we can see what that would look like. And it's going from 0. 0 is less than x. And notice I'm leaving the x, using the less than symbol because this is open. So that's why I'm using that symbol. But less than or equal to 12, meaning I can include the 12, so I'm going to underline that symbol there. So that's one way I can represent the function, the domain, with the inequality. But I could also represent this with an interval notation, where I know I'm going from 0 to 12, but I'm not including the 0, so I'm going to have my parentheses like this, but I am closing it. I want to include the 12. So I'm going to use that little bracket there. So because this tells me to include the 12. Okay? And I use my parentheses because it's to not include. Oh, I should put don't. Don't include the 0. All right, so those are the two ones that I can use for this answer. Again, I always like to do the math before I actually look at the choices. And with number 3, it has my inequality written out. So the domain of function is 3. I can't use 4 because those numbers, I'm not over there. Like, I don't have any values here from 15 on. So that's why this one doesn't work. And then when it comes to the notation symbol, the reason why 1 doesn't work is because it tells me to include 0 and 12. Okay, so that would be true if this was either filled in all the way, then 1 would work. But it ain't so. Or if I had something that looked like 0 is less than or equal to x, which is less than or equal to 12, then I can say number 1 is true. But again, that isn't so. That's not what we have there because we have the open circle. So now let's look at number 14, and 14 is a little bit more straightforward. We want the sum of 3 and square root 5. So what is true about this? Well, 1, if I'm thinking about it like adding like terms, I have an irrational number and a whole integer. I can't add these. Like, I would still represent it. Well, can I even represent it that way? Like, I can't add them together. I can't do anything with them. So let's look at the choices we have here. 1, if I tried to add them together, would this be a rational number? No. And this is where the calculator can help us out with this. If you were to do 3 plus, and I'm going to do square root second, square root 5, we were to try to add them together. Logically, will this be rational or irrational? It's telling us logically this is going to be irrational, which is what we have. Because it is non-terminating, non-repeating. So I can automatically get rid of choices 1 and 2. So this is definitely going to be irrational. We know this to be true. So now we have 3 and 4. So why is it irrational? The reasoning. Is it irrational because it is a terminating decimal? That is false. Or is it irrational because it cannot be terminating and repeating? That is true. So that is why 4 is our answer. And so if you're looking at this and you're like, is this true? What would actually, this is where using the calculator can help you with your reasoning. But as soon as you would have tried to multiply these two, add these two numbers, your brain should have been going, I can't combine them. This still would just be irrational. Hit pause, jot it down in your notes. Let's look at 15 and 16. For 15, the answer is 3. And for 16, the answer is 1. Let's break down why. For 15, we have here some exponents, and automatically your brain might be dinging back to a power of powers rule. And what do I mean by that? I mean, you might be thinking of something like this from 8th grade, where you have power of powers, and we can simplify this as 2 to the 12th power, where we're just, it's almost like you're multiplying these two. So if I have some type of term and I have an A and a B, whatever these are, I would just multiply them together. Oops, my base would be 2. And then I would just multiply A and B together. So this is my power of powers rule. And you might be thinking about that. And the reason why 1 and 2 do not work is because it looks as if someone tried. I can see a kid going and thinking, I can apply power of powers because A to the 4th minus B to the 3rd. And then squaring it. They might be thinking, well, isn't this just like A to the 4th and then times 2? This would give me A to the 8th. And then if I did the same thing with B, minus B to the 3rd squared, that would also give me minus B to the 6th power. So I can see why a kid will go, oh, that's why this has to work. But here's my question. If you were to go back and use, let's say, an area model, would that be true? Is that a way of deconstructing this? So what I mean by that is, if I went, here's my area model, and I have A to the 4th minus B to the 3rd, A to the 4th minus b to the third, would I end up with a to the fourth minus b to the third squared? Like, would I end up with that? Well, no, because when you actually try putting it in, when you multiply in the squares, a to the fourth times a to the fourth, I get a to the eighth. So that part seems right. And yes, when you do negative b to the third times negative b to the third, I'm going to end up here, negative times negative is positive, b to the sixth. But these two other values we have to multiply together too. And I'm going to end up here with negative a to the fourth b to the third, and at the same time a to the fourth b to the third negative. So I actually end up with, when I try expressing this, I will get a to the eighth minus 2a to the fourth b to the third plus b to the sixth. I end up with this middle term. That is why when we're squaring these binomials, I end up with a middle term here, and that is why it can't be equivalent to this one up here. So it's not going to work for this one, it's not going to work for that one. Okay? So it does not work. So now on the second one, for 3 and 4, this is where you can start thinking about your power of powers rule and actually applying them. So for 3, if you're multiplying these two out together, I do end up with a to the eighth minus, and the same thing with b, multiply these two powers, I get b to the sixth. And that's correct. That's using my power of powers rule correctly. For number 4, here, if someone were to pick this, you would get confused with adding them. You still have to multiply them together. So this would be a to the 12th minus b to the 8th. So that's why 4 doesn't work, because you're not adding the exponents together, you are multiplying them. This is a power of powers rule. They are not being multiplied together. Okay? Alright, so let's move on to number 16. And here we have the sum of 2 square root of 27 plus 4 square root of 12. Okay, obviously just looking at it this way, we can't add them up, but we can do some simplifying work. So for example, I see some square numbers in here. There's a square factor in 27. 9 times 3 makes 27. So not only am I thinking about that number in the square root sign, I'm thinking, does it have a square factor? Same thing with 12. It does have a square factor. 4 times 3. And this is super helpful because now I can rewrite this. Now because this is a square number, the square root of 9 is 3. So, boop. So now I have 2 times 3, which would give us 6. And the square root of 3 stays. Same thing happens over here with the 4. I know the square root of 4 is 2. So 4 times 2, which will give us 8. And square root of 3. And now I can add these two up because they're like terms now. 6 plus 8 is 14, and they both have a square root of 3, so now I can have a square root of 3. And that, my friends, is why the answer is 1. Alright, so the key to this one is when you see a number in that square root sign, try and think, if it's not a square number itself, does it have a factor that has a square number? And if both terms have the same square root symbol, I could actually add them up or subtract them. Alright, hit pause and jot this down into your notes. Let's look at numbers 17 and 18. The answers are 1 and 1. If you got these and you feel pretty confident, move on. If not, stay here. 17 was, how do I put this? It feels very wordy and very tricky in the way language is used. And what I mean by that here is you're trying to add Tim's age and Jack's age. And they're telling us that if you take Tim plus Jack, their ages, you'll get 44. Then they're also telling us Tim's age is, so I'm just putting Tim's age is 4 less than Jack's age, which is X. Okay, so 7 times Jack's age minus 4. Okay, so I need to kind of rewrite all this in a way that makes sense. So Jack's age is going to be X, and so Tim's age I'm going to make as Y. Okay, so let's rewrite this. That's the part that kind of bothered me when I first started thinking this through, is I had to keep on retranslating it in a way that made sense, and that's what can make this very tricky. So I could rewrite this as X plus Y is equal to 44. And Tim, remember, Tim is Y. Y is equal to 7x minus 4. So that's just me setting up a system of equations. And I need to have one equation, not a system, because I have two of them. This is my systems of equation. I need one equation for this. And the best way for me to do this is using substitution. And recognizing that because I have y equals 7x minus 4, I can take this expression and substitute it for y. And so I'm going to rewrite this as x plus 7x minus 4 is equal to 44. And that is what we pretty much have here for 1. Alright, notice the only thing they did was they have the 7x minus 4 in the beginning plus the x. So it is the same equation with the terms just moved around. But they are equivalent to each other. The same terms are in both. Okay, and that's where the answer is 1. So why are the other ones not true? For number 2, it's just that they would have written it wrong, where it's supposed to be 4 less than. And that's what matters here, that the 4 should be less than the 7x, so it should have just been turned around. And with the other ones, the 7x minus 4 equals 44, that is not true, because they're mixing up the two equations. So that's what happens with 3 and 4, where you're taking the two equations and kind of moving them together, but they're not equivalent. Let's look at number 18, and 18 is another one where if I'm super tired taking this test and I'm nervous, this expression would freak me out if I was already tired and nervous and I'm not feeling confident. But I'm going to show you how to go through this one in a way that hopefully makes sense. So I'm going to take this expression, 2x plus 3, 2 to the x plus 3 power over x squared minus 2. And because I want when g of negative 2, this is where I'm going to sub. So everywhere here, I'm going to put, where it says g of x, wherever you see an x, I'm going to put a negative 2. So 2 times negative 2 plus 3 to that power over negative 2 squared minus 2. And now you're just going to do some algebra. So 2, and now negative 2 plus 3 is just positive 1. Or just 2 to the first power, or you can just say it's just 2. And then on the other end, negative 2 squared, so negative 2 times negative 2 is just 4 minus 2. So what is 4 minus 2 equal to? 2. So I have 2 to the first power over 2, or 2 over 2. And 2 over 2 is just equal to 1. So this is one that if you're feeling anxious in the beginning, you might avoid it, especially if you're already not feeling the way it looks. But I promise you, if you just take a moment, sub through, look and see if that makes sense. Like once I have this is something you can chunk and you can simplify. And the same thing with this one here, chunk and simplify. All right, hit pause and jot this down into your notes. All right, number 19, we're looking for which one of these represents a function, and the answer for this one is 2. So what we're looking for here, we have a graph. I'm just going to do a VLT or a vertical line test, meaning if I draw a straight line down, it should only hit one time. If I draw a line, I'm thinking to myself, it should hit the function only one time. So which of these does it work for? So in this one here, it's a parabola. Yep, I can draw lines, even though it may seem like, yeah, but what about here? Am I hitting it more than once? It is a parabola. It is hitting just in one position at a time. So it does work for A. For B, yep, I can draw a straight line down. It's going to pass the vertical line test. For C, this one is a fail because I'm going to hit it I'm going to hit it on every single point here. So this is a fail because it is a vertical line straight down. And for D, because it's a circle, wherever I put this line down, except for maybe like right here, I'm going to get multiple. Even if it fails one time, it fails. This is a fail. Because that's all I need for one time for it to be true. So that's a fail. Here I can hit multiple times, so that's a fail. So it only works for A and B, and that is why 2 is the answer. It only works for A and B. Alright, let's look at numbers 20 and 21. 20 is another one. If I'm super exhausted, I can see myself making mistakes here. What were the answers for 20 and 21 are 1 and 4. So let's jump into 20 first. And we want to know how to rewrite this equation. K is equal to 1/2 mv squared. And we have kmv, not that important, but I want to write it in terms when m is written in terms of k and v. In other words, I want m by itself. That's all it's saying. Isolate for m. So let's kick off this bad boy. And first thing I notice is I don't want to deal with this 1/2. It makes it a little bit more complicated. So I'm going to multiply both expressions by 2. Because I want to simplify that 1/2. So on the left side, I get 2k. And on the right, when you multiply, you get 2 over 2. Because now I'm distributing, which is the same as 1. So now I only have 1 mv squared. And I like that. So let me just since I already have 2 over 2 is equal to 1. So 2k is equal to mv squared. Okay? Look at how much simpler that is now. Look at how much easier that is to work with. Now I want my m by itself. I can just divide this by v squared. And I'll divide this by v squared. Doing this will turn my right side into just 1m. Because v squared divided by v squared is just 1. So I'm left with m on one side. And on the other end, I could honestly just leave this. 2k is equal to v squared. And now you just look for which one matches it. I'm looking for this. And I see it right here. 2k divided by v squared. My answer is 1. Done. The key to this one, honestly, is just me working through that 1/2 by multiplying. When I see that fraction, if you multiply by the reciprocal. So if I have 1/3, multiply by 3. If I have 2/5, multiply by 5/2. And when you do that, now that just becomes 1. And it makes it so much easier to work with. Alright, let's look at the second one, number 21, which of course in the beginning also looks a little challenging. So let's just work through it. And we start off with 2 times 3x minus 1 divided by 3 is equal to x plus 2. So think about what I said before. If this is the thing that's bugging you, let's just multiply by 3. So I'm going to multiply this expression by 3 and this expression by 3. Here, this will cancel out, leaving me with 2 times 3x minus 1. On the other side, 3x plus 6. And now I can distribute. That's much easier for me to work with. There are no fractions now. I don't have to worry about anything. And now I can just distribute with the expression on the left, and I get 6x minus 2 is equal to 3x plus 6. So much friendlier to work with is this. Alright, so now you can just make some decisions about which ones you want to move over. I am actually going to subtract the 3x from both sides. And that leaves me with 3x minus 2 is equal to 6. Add 2 to both sides. And now I have 3x is equal to 8. Let's just move this baby over here for more space. 3x is equal to 8. And to isolate the x, I'm going to divide both sides by 3. So x is equal to 8 divided by 3. This one is just pure, beautiful algebra. And I just look for my answer, looking for 8 over 3. And here it is, 8 over 3. So again, the best way is to just, I'm not looking for tricks in this. It's just knowing and understanding what you can do with your equations, and just knowing that you can do things like multiply both expressions to keep it equivalent. It's not a trick, it's not magic, but just understanding that and knowing that to be true allows me to do so much work with these equations. All right, so let's hit pause so you can jot this down into your notes. All right, let's look at numbers 22 and 23. Ooh, I see a sequence for 22. Let's look at the answers first. The answers are 1 and 4. And I am going to use my calculator for number 23 to help us out. So let's start with number 22, and we have a sequence. And I see that my numbers are getting smaller, 12, 6, 3, and they're halving. I'm noticing a pattern here. This is not just subtracting by the same amount. This is a geometric sequence. Okay, meaning it's going down by a ratio instead. Okay, so thinking about how can I go from not subtraction with multiplication, how can I go from 12 to a 6, I can multiply by a half. From 6 to 3, I can multiply by a half. And you could even see it here, 3 divided by 2 by a half. So that's telling me my ratio is I'm decreasing by a half. That's what's happening here. Well, it's not negative 1/2, it's by 1/2. And that's just helping it to decrease because it's a fraction. All right, so A1 is telling me that's the starting point. And they want me to represent this as an equation. So this is where you can go and you can get your reference sheet. And in your reference sheet, you're going to look for the geometric sequence. And I'm going to write it down here because I don't want to put it up on the screen. You will get a to the n, which is your start, is equal to a1 times the ratio n minus 1. So let's break down what this means. A to the n is just telling us to any number. So if I want any number in there, like if I want n to the 5th or whatever, and you're going to take your start and you're going to multiply it by the ratio, and then you're going to get the number you want. Okay, so in this case they want us to know which equation. How do I write this whole equation out? I can leave the a to the n, and I have my a1, which is 12, times my ratio, which is 1/2, and I'm going to have it to the nth power, because they're not telling us what number we want. Like if they wanted the 8th sequence, then I would just do n minus 1. Okay, if that helps. So that's what we're looking for. But we could just leave it like here. And if they want the 7th, or let's say they want the 100th, I would do 100 and then minus 1. So that's it. That's all I'm doing, is I'm just taking this here and I'm literally just substituting A1 and R. That's all I did. And the one that matches it is number 1, where I substituted my A1, which is 12, and my ratio 1/2, and everything else stays the same. That's it. That's all you had to sub here. And let's look at number 23. For 23, they're looking for the axis of symmetry for the quadratic function where x is equal to 2. So that's what you're looking for in this one. So what do you see and what do you notice? Notice that I have two equations and I have a graph and I have a table. So with the first one being just a graph, I can literally see where my axis is right here. And here, this is where x is equal to 1, 2, 3. But that's not what I want. I want the line of symmetry, that axis symmetry, to be where x is equal to 2. So this is a no. On the table, I'm looking for where is that point where it changes. So I'm just going to go where x is equal to 2, and let's say that's right here. And I know that can't be it, because here I also have y would equal 6, and I get the same number on the other side. So I know that those are just two different. That can't be a vertex. Not a vertex. It's just a point. Because I get the same y value. Okay, so that doesn't work. So now I have my two equations here, and you might be thinking, all right, now if this was written in vertex form, super easy. And so you might be going, Sarah, what's vertex form? Well, if it was written to a form that looked like y is equal to, or f of x is equal to, let's pretend that. If it has something like f of x is equal to a times x minus some number plus some number, then I can take these two and this will be my vertex. It would just be hk. That would be my vertex. But these are not written in vertex form. They're written in standard form. So what I'm going to do is I'm just going to use my calculator for this, and I'm just going to put y equals. Let's clear this one. And I'm just going to put my first one, 2x squared plus 8x. And I am going to clear the second one out. All right, so I'm just putting in my first one just to see if it's true. And I'm going to graph it. And here, no, it looks like my vertex is at -2. So that doesn't work. So now I'm going to go back to my y equals, just clear it off, and I'm going to put my other formula in, x squared minus 4x minus 5. And let's graph it. And here, yep, there's my vertex if you were to trace it. You can see it like right around here, when that's where it is. That's where my vertex is, and it's pretty much where x is equal to 2. It's not exact, but I can see it. If you want to see it on the table, instead you can hit second table, and then you could also look for when x is equal to 2. And boom, you get that straight point. When x is equal to 2, my y is equal to 9, and you can see where the other points are starting to veer. So at 1 and 3, you get 8 and 8, so that this actually is the vertex. Where x is equal to 2. And again, the trick to this one is being able to recognize a vertex both on a graph, on a table, being able to see it, and if you can't see it in the equation, this is where the calculator can be very helpful, if it's not written in a form where it immediately comes to you and you can recognize it. All right, hit pause and jot this down into your notes. And here we are at number 24, the very last multiple choice problem, dimensional analysis, and the answer for this one is 3. So if you have 3, move on to the constructive response, but first check and look and see how many multiple choice you have correct, and give yourself 2 points for every multiple choice. If you're not sure how to get this answer, stay right here. Now, with dimensional analysis, we're doing a lot of our work where you just have to kind of remember, if you have the same rate or unit in your numerator and denominator, they can become 1. So if I have minutes over minutes, we say cancel out, but it's just because they become 1. So in this case, we want to know, we have Anna and the train, and we want to know which expression shows the railroad cars that pass by per minute. So I want cars per minute. That's the form we want. Challenge here is, I used to look at this and want to multiply all those numbers, and they're not even asking me to. They just want to know which equation is going to end up with that. So we're going to look at the first one. What I want you to look for is look for units that are the same in the numerator and the denominator. So for example, in number 1, I see miles, hours, and cars for my numerator. So I ended up with miles, hours, and car. And my denominators are hours, so those two can go away. Feet, minute, and feet. So ultimately that's not getting me cars to minutes, because instead I have miles squared times car and feet squared times minutes. So that is not what I'm looking for number 1. So we'll do the same thing with number 2. I want to look at it. I like to kind of look at it inside for a second and just look and see, do you notice anything? And I notice, let's see, does anything cancel out? Miles, minutes, car. Hours, feet. Ugh, this is another one where nothing cancels out. So I already know this is going to be a waste of time. So I'm going to end up with miles, minute, car, and hour, feet. Nothing canceled. Mile squared times minute times car over hours squared, feet squared. See? No, not what helps. So why does 3 work? So if you were looking at this, you will go miles, feet, hours, and car. And underneath, you have hours, so that goes. Miles, found one, found a pair. It's like playing Go Fish, right? And then, let's see, minute, nothing there. And then, feet, bam, and bam. So now that leaves me with cars over minutes, which is what I wanted. And that's why 3 is the right answer. But if you're a completionist and you want it to go to 4, then you can do the same thing. Miles, feet, minutes, car, hours, nope. Miles, yes. Hours, go fish, and feet. So, doesn't help. We ended up with hours squares, minutes times car. Alright, and that's it for multiple choice. There's usually always a dimensional analysis. I used to stress myself out actually multiplying out all the numbers, and then it kind of just hit me, I don't gotta do all that. They're not asking me that. They're literally just asking me which expression is going to give me that particular rate. And that's it for the multiple choice. Go back again and see how many multiple choice you have correct, and for each one give yourself 2 points. I hope this breakdown was really helpful for the multiple choice, and you can see how for most of them, honestly, I don't even look at the choices until I do the math. There are very few that I actually have to look at every choice, and that's usually when they're saying which statement is correct, and I have to look at all of them and eliminate the ones to discern which one is absolutely true. Alright, hit pause and jot this down, and we'll get ready to jump into the constructive response. Let's jump into our very first constructive response problem, number 25, which is a frequency table. I really like these because they're just like logic puzzles to me. So let's figure out how to fill it in. I'm going to have just my highlighter ready. A survey is taken to determine whether students prefer to watch videos with some music. Over one of the 100 students surveyed, 44 were seniors. So we know in total there were 100 students and 44 were seniors. So this is like a part to whole. Like, remember when you were in middle school and you had to do part to whole relationships? So we know the whole thing is 100. We know one part is 44. So what would the rest of it be? Like, this is kind of what it looked like when you were in middle school. If this part is 44, what does this part have to be? And you can just use your calculator for this and subtract 44 and you will get 56. So 56 are juniors. All right, let's keep on reading. And we have of the 65 students who prefer to watch videos. So we know that there are 65 who like to watch videos, 42 are juniors. So here's my 65, and we know 42 are juniors. So the rest of them have to be seniors. So you can, again, just use your calculator. 65 minus 42, and you get 23. And I'm using it just as a tool, not because I don't want to do the mental math. I just want to be careful at this point. But I can see that all of these add up to this number down here. 42 plus 23 and 56 plus 44 equals 100. Now, for this middle row, you can still figure it out because now you can just add down the other way. 42 plus what will give you 56. And if you're doing your math in your head, you can probably just figure out it's 14. 14 plus 42 is going to give you 56, and you can do the same thing here. 23 plus what is going to give you 44, 21. And then you can do the last one. 65 plus 35 is going to give you 100. And that's basically what it is. You can double check your work by just adding. And you can just double check here, whether it's on paper. You can just do 42 plus 14 equals 56, check. 23 plus 21 equals 44, check. And 65 plus 35 gives us 100, check. And then you can just add the other way around to get these numbers. Just triple checking. Oops. 42 plus 23 gives us 65, check. 14 plus 21 gives us 35, check. And 56 plus 44 gives us 100, check. And that's it. You just have to fill out the whole table with these exact numbers to get points. If you do all the numbers correctly, you'll give yourself full credit, 2 out of 2. If you have maybe one error that kind of carries over, like one of these numbers is off, that affects the other one, you may take out 1 point and give yourself 1 point out of 2. Score yourselves, and if you didn't know what to do at all, you would give yourself 0 points. Another 2-point question, and there's another inequality. I do notice that on this test, there are a lot of inequalities. So many of the questions had to do with that. But the algebra is still basically what you're going to work with. So in this case, we need to solve for y. And you're going to start off by just distributing. So here I'm getting 10 minus 5y, remember both terms, is less than negative 11y minus 8. So that's all I did in the beginning. I distributed. All right, now I do want to decide where the y is going to be. I'm just going to decide to add, just because I tend to prefer adding to subtracting. So it gives me a 0 pair here. And here I have 10 plus 6y is greater than negative 8. Okay, so addition property of inequality. I want the y to stay on the left side, so I'm going to subtract 10 to create a 0 pair on the left. And here I have 6y is less than negative 18. Okay, so far so good. And now I can isolate the variable y by just dividing both sides by 6. And y is less than negative 3. And done. If you get to this point, y equals negative 3, then give yourself 2 out of 2 points. And your work has to demonstrate that you know how to do this. You couldn't just put the final answer. You have to be able to show all the steps of work. Now, obviously, if you had some type of computational error that was small, that doesn't take away from showing that you know what the steps are, you can have 1 point out of 2. But if you were completely far off, making a ton of mistakes, you would give yourself 0 out of 0, or if it was blank. All right, so hit pause and jot this one down into your notes. I do want to say that if we had divided by a negative 6, just throwing this out there, if we were dividing, and this is not true, if we were dividing by negative 6, then we would have flipped the symbol around as a final answer. But that did not happen in this case. But know that that is a convention when we're working with inequalities and solving for a variable. All right, score yourself, hit pause, and we'll move on to the next one. All right, for number 27, we need to multiply these two binomials to make a trinomial. There are two ways I can see you doing this. First is using FOIL, and the second one is using an area model. If you've seen my videos before, you know I have a preference for area model, but I can see why FOIL works, and it's actually how I learned as a kid. And FOIL is just an acronym that helps us figure out how we're going to multiply by doing two terms at a time. So the first numbers, the outer numbers, the inner numbers, the inner terms, and L is for the last ones. Okay, so first, and then outer, and then inner, and then last. Okay, so we'll start with, and I'll just write them here so you can just see them. And honestly, because we know we've been multiplying for a long time, the easiest place to make a mistake here is just with the positive and negative numbers. Very simple. Happens all the time. So I'm going to start with the first one, and I want to keep my work as organized as possible so I can see what's happening, and I'm more likely to be aware if I make a mistake, which is totally natural. So with the first ones, I'm going to multiply the first terms, the 5x times the negative 2x, and that is equal to negative 10x squared. So those are the first terms in both binomials. Let's go to the outer ones, and that's my 5x times 7, and that's just 35x, positive 35x. Let's go to inner, so those are the inside ones here, and I have negative 3 times negative 2x, so that is a positive 6x. And my last one, and again, this last terms, I have negative 3 times 7, which is negative 21. So now I have all my terms. I'm just going to rewrite it. Negative 10x squared plus 35x plus 6x minus 21. Here are my like terms, so I can simplify this into a trinomial. Negative 10x squared plus 41x minus 21 as my final answer. Done. And this makes it easier. It's so organized, I can look to see and just double check any of my work there to make sure I didn't make any silly mistakes. Now, the other thing you could do here is an area model. So let's show that one. I love a good area model. If you prefer FOIL, that's great. I learned FOIL as a kid, but area model just sunk in for me. So obviously you don't even have to use one of these ways, but I'm just showing both side by side. I'm going to do a 2 by 2 square because I have two terms, 5x minus 3 and negative 2x plus 7. And now I'm just multiplying and putting those numbers in the boxes. So with the first one, negative 2x times 5x is our negative 10x squared. You'll notice the same thing we did here. And it's just so that we can multiply two numbers at a time. So here's 6x, here's 35x, and here's negative 21. So same things, you're going to see these are the exact same terms that we had before. And some kids tend to see like our like terms are going to be in a diagonal. So when you rewrite it, when you combine them, I still get negative 10x squared. I'm going to add those together to get positive 41x minus 21. Either way works. Use the one that makes the most sense to you. If you had the same answer, awesome. Give yourself 2 out of 2 points. Remember, you have to be able to demonstrate how you got that answer to get the full credit. If you had some type of computational error, you can take away 1 point as long as it shows that you just made some type of calculation error, but it wasn't a big error in terms of how you understood it. And 0 points if you were way off. All right, score yourself, and we'll see you in the next problem. All right, for number 28, we have a sequence. It is an arithmetic sequence, meaning there's a constant. I'm adding a number, either a positive or negative number, but I'm adding the same amount, like constantly the same amount. Okay, and we know the first term and we know the fourth term. So they're giving us the first number, and they're only giving us the fourth number. That's it. That's all we got. But we need to determine the eighth number. So in other words, we need to figure out a to the eighth. Now the very first number is a to the 1. That's our start. So we have that. So where do we go from here? How do we do it? Now, if you go to your reference sheet, you're going to see an arithmetic sequence algorithm, and you're going to see something that looks like this. A to the n is equal to, so I can find a to any number as long as I have the first number, the starting number, plus my constant difference times the term I want minus 1. So D just means my constant difference, how it's changing, what I'm adding each time. And I just need to know where to start, and I want to know where to end. That's it. Okay? So in this case, we already have some of the information. We want the eighth number. We know the first number is -20, but what we don't know is my constant difference yet, but we know we want the eighth term, so we're going to do 8 minus 1. All right, so let's figure out this constant difference here. Now, I know that if my numbers go from -20 to -2. So it made a change of 18. That's what we know so far. But that's if I skipped all the way to the fourth number. I skipped 2 places in the middle. So what would that be? Okay, so let's think about that for a minute. So if I skipped all 3, like 3 jumps, I got to 18. But what if I want to jump 1 at a time? So I'm just going to say, well, what if I just divided this by 18? I would have a constant difference of 6. This means that each time I'm adding 6. So -20 plus 6 is -14. -14 plus 6 is -8. And -8 plus 6 gives us -2. So this is my constant difference. D is equal to 6. Now that I have that, I have enough information that I could either keep the pattern going or I can use the algorithm. Because I started with the algorithm, I'm going to keep going with the algorithm. So I'm going to take this and put 6. And now we're just going to simplify it. -20 plus 6 times 7. -20 plus 42. And -20 plus 42 is just 22. So a to the 8 is equal to 22. Now, let's say you didn't know this. Could you figure this out? Do you have enough math sense to figure this out? Absolutely. As long as you figured out that the constant difference was 6. So here's what I mean. So you started off with -20. That was the first number. And then we knew the second number was 14. The third number was, -14, -8. The fourth number was -2. Now you just got to keep the party going. So -2 plus 6. This comma's bugging me. So -2, if we added 6 to that, we will get to +4. That's our fifth number. And if I wanted to do the next one, -4 plus 6 would give us 10. That's the sixth term. Just so you can see where, all I'm doing. So you could figure this out by just keeping the pattern going. 10 plus 6 is 16. That will be the seventh number. And 16 plus 6 is 22. That would be the eighth number. So boom, even if you didn't know what the sequence was, or you didn't know how to use your reference chart, as long as you could figure out what's the pattern, how are my numbers changing, as long as you recognize that my constant difference was 6, that I kept on adding +6, you can figure out the eighth number. Alright, for number 29, we need to write an equation in slope-intercept form. The line has to pass through this point, -2, 5, and it has to have a slope of 3. Again, many different ways you can do this, and I made this a little smaller because there are 2 ways we can do this. One is to use the point slope form, and we can use that formula, or 2, you can derive it from graph. I'm a fan of number 2, but I recognize there are some people who would like to do it algebraically. So let's start with that one, which is the point slope form. And for that one, you would use this formula, y minus the point you have. So this is awesome if they give you a point. So the point that you have, the y part of the point you have, is equal to m, which we also have. They gave us a slope, and x minus the given point for x, the x coordinate. Okay, so now this is just substituting from here on out because they've given us everything else. So we can do y minus 5 is equal to, we know what m is negative 3. Negative 3 times x minus, and this is the only place that can be a little tricky, x minus our negative 2. Okay, so let's just fix this up. So this becomes x plus 2, and we're gonna just distribute, and you get negative 3x minus 6. So y is equal to, not equal to, y minus 5 is equal to negative 3x minus 6, and then I just add 5 to both sides. So you get the equation y is equal to negative 3x minus 1. Easy peasy, right? Not so bad. That's why I get it. A lot of people love this form, especially because they gave you the slope anyway, and they gave you a point. So this works very, very well. Now, why do I like using the graph? Because I just have to put in the point, negative 2, 5. So negative 2, 1, 2, 3, 4, 5. Here's my point, and I know my slope is negative 3. So that just means I'm going to go down 3 over 1. That's it. Down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Because all I really need is this number right here, which is my y-intercept, which is at 0, negative 1. Now with that, I can write my equation in slope-intercept form. Y is equal to mx plus b. I already have my m, which is negative 3, and now I have my b, which is negative 1. Either way works. Choose the one that makes the most sense to you, but I think it's also a lot of fun when you know both ways. It just makes it more flexible, because what would have happened if I would have tried graphing it and this wouldn't have been like an easy point? So that could happen. It could happen that it doesn't work and I don't have a clean intercept, and then I would have to use slope form. Or what would have happened? I think this is our last 2-point problem. We need to factor the expression. It's a binomial. We need to just factor it completely. That's all they want us to do. So I'm going to start by just rewriting it. X to the third minus 36x. And try and think, what can I factor first? I can take an x from both terms. So that's my first common factor for both terms. Okay? So typically it's going to be, in this case, just a variable. And when I factor this out, I end up with x squared minus 36. Awesome. Now from this point, I can try and think, is there a way I can factor the x squared minus 36 more? And you might notice that I have a difference of 2 squares, where x squared is a square, so this is a square number, and this is a square number. And I notice that I have minus a square number, so that's what makes it a difference of 2 squares. And that means I can express this as x plus 6 and x minus 6. And that's it. This is now completely factored. Okay, but again, this only works when I have a difference of 2 square terms. All right, completely factored. So score yourself as a 0, 1, or 2. Here you can see how I factored out the x first, and then I found a difference of squares to factor the rest of it out. give yourself a 0, 1, or 2. If you just had the x plus 6, x minus 6, then you may lose a point there because you have to make sure you had this part as well. All right, hit pause, score yourself, and we'll start jumping into those 4-point problems. Here's our first 4-point problem. We need to graph these two functions. The first one is actually pretty easy to graph. Actually, you could graph both of them manually, but I do want to use my graphing calculator because you're going to notice something with the points, and it's so helpful when you can graph it and look at the table of points. It just makes it easier. So I'm going to actually do that. So we're going to go to our table. Let's clear this out. Our y equals, me clear it all out. And I'm going to put in my first term minus 3x. And then I'm going to go to my second one, x squared plus 2. And it might tell me something about the minus part when I try graphing. Oh, there you go. So here are my two functions, my negative 3x. And what I'm going to do is you could trace it if you wanted to, but I actually want to go to the table. So hit second and table. And this is super helpful because now I have points that I can really graph. So with the first one, I'm just going to do the point 1, negative 3. And then 2, negative 6. And then 3, negative 9. And honestly, I could have seen, if you're not seeing the other points, remember you can just move up and you would have gotten to 0, 0. And then 1, negative 1, positive 3. Negative 2. And I'm just following. So the linear one is pretty easy, right? Pretty easy to draw a line. You can draw the straight edge on it. You can use a straight edge to go through the points, which I should have done. So let's use my ruler here. Okay, awesome. There we go. Now for the parabola one, I'm going to go and look at those points as well. And I have my first point at 0, negative 2. And I'm just putting in my points in there. So I have 1, 3. Oh wait, add 0, positive 2. 0, positive 2. And this is where I'm moving down to. 0, positive 2. And I notice here at negative 1 and 1, I have 3 and 3. So here, this is a point where I'm noticing that I have a point of intersection right here. So at negative 1, 3. And then I go to, I keep moving to the next one up, and I have a negative 2, 6. Up, and I see again my y values are the same. So there and there. So there's my parabola, and I can go to the next one. At 3, it's negative, it's positive 9 and 11. So I just would have gone off from there. All right, so now here we go. But now my parabola has to go through here, because there's my graph. All right, so now I can see the 2 points, and this is kind of why I like using the graphing calculator for this, because I probably wouldn't have seen that those 2 points are touching. And even with a straight edge, they weren't exactly like my line isn't exactly through those points. So that's what makes it super helpful. And we want to be that careful to show that those are the 2 points of intersection. So in my work, I'm going to add those. It tells me just to state the 2 parts where f of x is equal to g of x. And it's true at, I just want the x values, mind you, when x is equal to negative 1 and negative 2. That's all they're asking me, for which to state the values that satisfy it. So that's what I put there. So I can, and those are the points that I saw. Now, if they wanted more evidence, like not just state the values, but they wanted me to demonstrate or to justify it, then I can algebraically justify it using substitution. But because they only said to state, that's all I did was to state it. All right, so now go and look at your work, and you're going to score yourself out of 4 points. Did you graph both of them correctly or pretty accurately? And did you answer both values of x that will satisfy the equation? So all those things need to be true to get full credit. Score yourself as a 0, 1, 2, 3, or 4. All right, let's move into 32, and 32 is another pretty straightforward one. They want us to solve using the quadratic formula. Luckily, this is another thing that we do not have to know by heart because we have a reference table for it that tells us a quadratic formula. So I'm just going to reference it and rewrite it in there just for muscle memory. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And besides that, I'm going to look at my equation and put in my a, b, and c terms. So my a is equal to 6, my b is 2, and my c is equal to negative 1. I need all of that. Now, silliest thing for me is that I end up having all this space, and I end up writing so big that I swear to you, there have been times I've gone and done this, and like half the page is just me writing the formula and the ABC. So just use a little corner, please, so you have enough space to work and you don't feel stressed out. All right, and now all I'm going to do is substitute now that I know what my A, B, and C is, and I'm just going to rewrite. So give yourself space, step at a time. So I know what my B is. My B is 2, so I have to put negative 2 plus or minus square root of 2 squared minus 4 times 6 times negative 1 all over 2 times 6. That's it. All I did was substitute. Now this is where I'm going to start simplifying it out. A very simple place some kids make a mistake is that they might just put the 2 here, but remember it has to be negative the b. Now if b was a negative 2, then I would have to put minus negative 2, and I would have to work through that. So just be aware of that in case it comes up in future years. All right, so luckily this doesn't have to be simplified here. Plus or minus 4, and now it's negative 4 times 6 is negative 24 times negative 1, so now this becomes a positive 24. Honestly, silly place to make a mistake, but it does happen where some kids may have a negative 24. So just look out for it. And this is again why I slow myself down very intentionally. And 2 times 6 is just 12. Okay, so far so good. So now I keep going again. Negative 2 plus or minus the square root of 28 over 12. So this is where you're going to start thinking, square root of 28, do I have any square factors in 28? That's what you're going to think about. And it turns out you do, because you can turn this into 7 times 4. And 4 is a square number. Okay, so now that you have that, you can simplify it to x is equal to negative 2 plus or minus square root of 4 is 2, and square root of 7 stays inside over 12. And now there is nothing more that I can do. I can keep this in radical form, so I can leave it like this. Now, sometimes there is this desire, I guess some kids want to go further and they want to try and keep solving it. So that is something that I've seen some kids do, but just thinking through, they said that we can leave it in this form. If you wanted to, and these are other things that I've seen some students do, what if they want to simplify it even more? Like I want to find the square root of 28 not necessary. So just leave it as is what I'm telling you, to get a complete answer. Okay, now if you wanted to, you could go and simplify. Let's see, let's say I wanted to simplify these here, and I can have 1 negative 1 plus or minus square root 7 over 6. It's equivalent. It's okay. That you could do if you wanted to, but this is okay, and this is okay. I'm trying to think if there are any other ways that you can get full credit for this one. I've seen, let's see, I could also see some kids doing, what could I see them doing? What if they went and instead they did this? So negative 2 over 12 plus or minus 2/7 over 12. And I could see someone simplifying this and doing negative 1/6 plus or minus 1/6 times square root 7. So I could see this also being true. But you can see how, like, I've noticed a lot of kids who they kind of want to keep going, and there's just more room for error. So if you had any of these three, I can see having a complete 4-point response. So any of these can work. All right, so hit pause and jot this down in your work and see, again, give yourself 4 points if you had all of this. Now, if you had any other errors in there, you will start deducting from there. All right, number 33 is a linear regression. There's always a linear regression. I'm just used to there always just being this type of problem. So for this one, you absolutely need your graphing calculator. What we're going to do is we're going to go into stats, go to one edit. Notice I still had questions from before, so I'm going to just clear it. So we have our numbers. And I'm going to just put in our numbers in here: 0, 3, 6, 9, and 12. And then on the other side, 1200, 1150, 1100, 1000, and 920. Okay, so we have all our numbers in here, and what we're statistically doing is just figuring out, is there a correlation between these two values? Is there a correlation between the time since the months, time since it was released, and the price in dollars? That's all we're looking for. Is there some type of connection? So now we're going to go back to stats, move over to calculate, and you're going to go down to 4, linear regression, and hit enter. We want those first two lists, 1 and 2, and calculate. And now this is going to give us the information that we want. So y is equal to ax plus b. We have our a is equal to, and we have to round this, so they're asking us for the equation to the nearest hundred. So our a is equal to negative 23.67. So I've rounded it out. And we want our b is equal to 1,216. So now I just have to write this into an equation. So y is equal to negative 23.67x plus 1216. And that's it. That's all you have to do for that first part. In the second part, they want to know the correlation coefficient. That's just your r. And so here, again, rounding to nearest hundreds, our r is negative 0.99. Why did I do that? Because I had 0.989, just saw negative, and you look at the buddy behind you, and if it's 0 to 4, round down, but because it's more than 5, round it up. So that's why I rounded it up. Okay? So that's all we had to do for the second part is to write down R and round it. And so for the last part, we have to state, is it a linear fit? Is there a correlation? So again, we're looking at our R, and from a scale of -1 to 1, if it's close to -1 or 1, it's a strong correlation. It's either a strong positive or a strong negative. If it's close to 0, it is a weak correlation. So here, strong, strong, weak. Our R is a -0.99. Very close. So here's where our R is, which is a strong negative correlation. So that's what we need to state. The correlation coefficient indicates a strong negative correlation. That's basically it. That's all they're really asking for here. Is it a strong or a weak correlation? Now, I could go even further and explain that and justify it and what this means. And pretty much what we're seeing is as more months grow, it increases, the price in dollars decreases. That's basically what it means. So if you wanted to justify it even more and explain, you could. As the number of months increase, price in dollars decrease. The number of months and price strongly correlate. And boom, that is it. So this is actually one of my favorite ones to do for a 4-point problem. And literally it helps the most if you know how to use your calculator and if you know how to use those numbers and know what they actually mean and not just plug and chug. All right, hit pause and jot down, is this a 0, 1, 2, 3, or 4-point response? And remember, the easiest place to make an error is really just with the rounding or if you enter the wrong numbers in the calculator. All right, hit pause and score yourself. I think 34 was probably the one that upset a lot of kids. Because we have a system of equations, but one of them is a quadratic, and they probably weren't used to that. But we can still use algebra in order to solve this. And I would use substitution for this one. This is the one that seems to make the most sense to me. And it starts off by rewriting particularly the second formula. So y minus 2x is equal to -6. I'm going to add 2x so that it's more in a y-intercept form. So y is equal to 2x minus 6. I want that because now I have y equals is equal to y equals. So I have two things I can set them equal to. And so I can do 2x minus 6 because that's equal to y. And so I can just write, well, y is also equal to x squared plus 9x plus 4. And I can set these equal to each other. And now this is a quadratic that I can solve. So that's what I love about this. So I'm going to set this equal to 0 by subtracting 2x and also by adding 6. Okay, because I know this will make a 0 pair here. So I have x squared plus 7x, and then minus 6 plus 6 is going to be another 0 pair, so I end up with plus 10. Okay, so now this is set to it's a 0, which is what I want. Now I can use what I know about factors, my factors of 10. Get your factor pairs ready to figure out how to, what are the factors of 10 that would make positive 7, that would add up to positive 7. So I have 1 and 10, 2 and 5. Obviously, it's going to be my 2 and my 5. So x plus 2 and x plus 5 is equal to 0. So with this, now I can solve for x. X plus 2 is equal to 0, and x plus 5 is equal to 0. So x here is equal to -2, and x here is equal to -5. With this, I can find my y values. All right, so this is a complex problem because you have to know how to work with the quadratics here. So now that I have this, I'm going to use my easier equation, honestly, to do my substitution. So y is equal to 2x minus 6. Y is equal to 2. I'm going to do the negative 2 first. Times negative 2 minus 6. So that's negative 4 minus 6. So y is equal to negative 10. And that means my first coordinate is going to be negative 2, negative 10. And now I could do the same thing with my second one. Y is equal to 2x minus 6. Substitute. Y is equal to negative 10 minus 6. Y is equal to negative 16. And so here, my second solution is negative 5, negative 16. So these are my solutions to the problem. So here's what I also want you to consider and to think about here. There's some kids who they want to keep on going and going further and further, but all I needed to find was both solutions. That was it. Not only did I find the solution for x, because it does ask me the solutions for x and y. So if you just stopped, and there's some kids that just stop here, but they want x and y. That's why I had to keep on going and getting these points. Okay? Now, if you wanted to substitute and double check that it works with a quadratic, you can, but this should satisfy everything. So this is where I want you to stop, score yourself, and this is the 4-point problem, and see how many points you would have gotten. Were you able to substitute and set both of them together to create the quadratic and solve? Were you able to find the solutions for x with the quadratic? And then were you able to substitute to find the solutions for y and have the 2 points? That's what you're looking for. If you did all those things, you give yourself 4 points. Now, if you only have parts of those things, like you only gave the y values, I would say maybe 2 out of 4 points there because you just didn't finish it off. But I'll look at I definitely want to go back into the scoring guide to see if that would have been true. Nevertheless, hit pause, score yourself as a 0, 1, 2, 3, or 4. All right, we're at the very, very end, the very last problem, the 6-pointer, and typically this one threw me for a loop because for the past few years, it's typically been a systems of equations for the 6-pointer, and you saw how they just use a system of equations with a quadratic. And I think so that threw some kids off. And here we have a systems of equations with an inequality. So a systems of inequalities, not even a systems of equation. Mathematically, I can see why that throws a lot of kids off because they just don't practice this enough, and it's even making me reflect that I need to give more practice like this for kids in my program. So I'm going to jump through this and show you all how to get as many points as possible, full credit 6 points, and how I broke this down. So in this one, Sarah, love that name, she earns 6 hours babysitting and $12 an hour tutoring. And her goal is to get at least $120 per week. And she's allowed to work a maximum of 14 hours a week doing both jobs. Okay, so both of those parts are super, super important. So let's start thinking, how do we want to express that? So the first part is pretty easy. Wait, there's more. Let me finish reading. X has to represent the number of hours she babysits, and Y has to be the number of hours she tutors. Okay? All right. So the first part is pretty easy. I'm going to have 6x plus 12y can be greater than or equal to $120 because I want her to make at least 120, but she can make more than 120. And we also have that x plus y can be equal to 14, but it cannot pass 14. It's less than or equal to 14. So I have to have both of those for my systems of equations in my model. Okay, so that's the first part. So now we need to graph these. I'm going to start with the first one, and what I would say, I want to graph the first equation. What I would say with this one is it really helps if they're in slope-intercept form. Just saying. Makes it easier. So let me take that first equation. And I'm doing this without the calculator. Like, I know a bunch of people just want to put it into a calculator. I don't want to do that right now. So I'm going to take this. I'm going to subtract the 6x from both sides. And I have negative 12, positive 12y is greater than or equal to negative 6x plus 120. And I can divide all of these by 12. Okay, so now I have y is greater than or equal to 1/2 x plus 10. That one I can kind of graph pretty well because now I know my intercept is here at 10, and I know my slope is down 1/2. Okay, so that's the first part. I can graph, let's connect all these lovely dots. And because I have y is greater than, I want this part up here. Okay, so that's part one. Pretty simple. I'm even going to write this as my line. This was negative 1/2 x plus 10. Okay, now the other one, I have x plus y is greater than, is less than or equal to 14. This one's easy enough. I'm just subtracting x on both sides. So y is less than or equal to negative x plus 14. Also not so bad. So here's 14, and my slope is just very simple, negative 1. Pretty easy. So I'm just going down this line. Now, luckily with both of these, they're both solid lines because they didn't have dashes. They weren't like less than or greater than, they were less than or equal to. So, and I have my point of intersection right here at 1, 2, 3. So that would be 8, 6. Okay. And for this one, it's my y going down. So I'm going to pick a different color. Okay. And so where's my common solution set? Boom. Right here. This is where they both interact. They both overlap with each other. So I'm just going to write, just so I have it here, y is less than or equal to negative x plus 14. Okay. Awesome sauce. There's my solution set. So just for this part, because I'm going to change screens for a second, I don't want to move it until you see where I have this part. So just check, look to see, does this make sense? And if you want, you could test any of the points within that solution set. Okay, so now let's go to the next part. And the next part is asking me to, because I'm going to have to flip back, state a combination of hours, babysitting, and tutoring that will satisfy the solution. So I just need a point in here. Just any point in there. Alright, so I'm going to choose, like, I like just easier numbers. So how about the point 1? How about 110? Okay, it's within the set. Let's try it out. And that means I have to rewrite my two equations. So let me rewrite both of them. So I had y is greater than or equal to 1/2 x plus 10, and y is less than or equal to negative x plus 14. that was my y equals, but let me actually do the other equations. And those were, I kind of like this one better. 6x plus 12y is greater than or equal to 120. I'd rather use these. And I'm going to substitute the 1 and the 10. So 6 times 1 plus 12 times 10 is greater than or equal to 120. 6 plus 120 is greater than or equal to 120. 126 is greater than or equal to 120. So that one worked for the first one. And now I'll use my second set. X plus y was less than or equal to 14. And 1 plus 10 is less than or equal to 14, and that's true. 11 is less than or equal to 14. So this combination works algebraically, and now I just need to justify it because it's asking me to state the combination of ours, which I did, that satisfies and justifies the equation. So if Sarah babysits for 1 hour and tutors for 10 hours, she will meet both conditions. She will earn more than $120 and work less than or equal to 14 hours. She will earn, so that's the only thing I want to change here. She will earn more than, that's the only thing I'm going to change here, more than or equal to $120 and work less than 14 hours. C, work to justify my answer. And done. So this is everything here for my 6 points. So I'm going to just go back. You need to be able to create a system of inequalities, meaning you had to have both inequalities written out. Then you need to be able to graph both inequalities and find the solution set. So that was really important. Notice I stated it, I showed it, put it all in there. Then you needed to pick any combination point. This is where your numbers can look very different from mine. You just have to pick a point. I just chose 1 and 10 because they were easy numbers. To be honest, that was why. I just wanted to multiply with very easy numbers. I proved it. I justified my answers by subbing it into both equations to make sure it was true. And then I explained my answer in full words. And that's it. So what you're going to do, again, I've only seen one other time in like 10 years that they have done a system of inequalities for 6 points. But lesson learned, we just need to be prepared for everything because we can definitely do this math. We just have to practice it in order to be ready. So what I want you to do now is score yourself from a 0 to 6. How did you do on this problem? I hope this helped make it easier. And in the next chapter, I'm going to show you the point values for what you could have gotten if you had taken this very test. Okay, you could have gone back and added up all your points, the 2 points from all the multiple choice, all the constructed response, and that will give you your raw score. Your raw score out of these 82 points is going to tell you what, how you would have scored if you took this test for June 2025 on that date. So for a level 1, to get to a level 2, you needed at least 18 points. Anything less than 18 points would have been a level 1. To get to a level 3, you needed at least 29 points to get to a level 3, which is a 65 on a Regents. Now, if you were going above that to get to a level 4, you needed at least 51 points to a level 4. And if you were aiming for a level 5, you needed at least 70 points. So this is the scale, again, only for 2025. And what I mean by that is each and every year, the scale kind of changes a little bit. Like some years you need 30 points to get to a level 3. Some years it's 31, some years it's 28. It changes. Sometimes in January it's a little different than it is in August. So this is a rough estimate for if you had taken this exact test, this is what the scale scores would have been. So this is what I'm going to tell you. If you're planning on doing the August Regents, I say pretend like you're training for a marathon or a game. If I'm playing a sports game and I want to be strong, I work out with a weighted vest on because I want to be stronger. Because that way, if I start jogging with a weighted vest and it feels heavy, and I build up that strength and endurance now, when I do it for real and I take off that weighted vest, I'm faster and I'm ready and I'm prepared. So what I would tell you is if you're using this video to help you study for a test, do a weighted vest, meaning aim for maybe plus 3 points. Because you don't know what the scale is going to be. So it could change. Instead of saying like, oh, I only need to get 29 points to get to a 3, add 3 points to that. And say, let's say I really want to aim actually for like, maybe add 32, 33 points. Maybe you want to add some more to it to be more safe, for a safer number. So maybe I'm really aiming for 32 points. Or if you want to be very conservative, aim for plus 5, which would be at 34 points. That's just if your goal is to get to a level 3. If you're really aiming for that 4 or that 5 because you want that strong Regent score, then again, aim for either 56 points or aim for 75 points. Like, add something to it. Don't just go for the bare minimum. Try to jump above that. Aim for higher above that. So that way, like, let's say the test is a little bit harder the next year, you're ready for it. Or let's say like the scale changes and a lot of kids did better, you're still aiming for above that. And that's where I really want to challenge you. Don't just go for the bare minimum. Try to really challenge and push yourself to be more conservative and to really train like you're trying to get stronger for this, and aim for 3 to 5 points above these numbers. So that's it for today's video. I hope you found it super helpful. This was a year where I saw a lot of kids struggling because they changed some of the questions around, like the ones I mentioned, quadratics and inequalities. But this is all math we can do. So we're not trying to teach to a test, but I do want to make sure that in my videos I can help you understand the math, because you can totally do this as long as you're really practicing and pushing yourself to understand. So if you have questions, leave some comments, leave it in the comments. If there are videos you would like me to do to help you prepare for Algebra 1, let me know. And with that, Math Marvels, I will see you next time. Take care. Bye.